morning, everyone. I hope you are having a nice show. I hope you are enjoying as much as we do. Please make yourself comfortable. We're going to have a 25-minute session together. My name is Sébastien PANTHU. I'm from Huntsman Advanced Materials. I'm in charge of the new business development for Composites. And I'm here today to talk to you about epoxy innovations for composites in tomorrow's mobility. So mobility is currently changing. This is driven by the greenhouse gas emission reductions, CO2 emissions reductions. So we see today a turn into the mobility, going to electrifications, use of new kind of energy. So in this presentation, I will first give you a quick introduction about advanced materials. I will explain also how we tackle the topic of sustainability, because we believe that we have responsibilities in this area as a chemical player. And then I will list some of the solutions we recently developed to adjust and to satisfy the requirements of those new mobility applications. And I will give few words about the support that we bring together with our products. So Huntsman Advanced Materials is part of Huntsman Corporation. We are a specialty chemical supplier. We are one division of Huntsman Corporation. We have been active for more than 60 years in this composite business and automotive industry. We are specialized in the epoxy resin formulations, and we serve different markets. We have a global footprint in terms of research centers, manufacturing sites, development offices, and so on. And we serve several markets like aerospace, automotive, adhesives, power, wind energy, coating, and of course composites, industrial composites linked to transportations. So, building a sustainable future. I will try here, actually, because we see so many greenwashing presentations those days, so I will try to focus on facts, and I want here to bring actually key actions, and even short-term, even if we have longer-term responsibilities and longer-term actions. So we do take our responsibilities those days, because as a chemical player in the industry, it's really important. So it's not a nice to have, actually. It's a must to act and to do something. And it's not for long term, it's also acting today, for tomorrow, and even for longer term. So we discuss with our customers, we check the regulations, we check whatever is possible to do to put some concrete actions in place. We act basically on 4 different elements. So the first element is the use of renewable raw material in our products, in our epoxy systems, in our epoxy resins. Actually, we've been using bio-renewable resources for more than 10 years now, so almost for a decade, basically. And so we were not really communicating on this before, but this was already part of our DNA and part of our products. And of course, to quantify this, to analyze this, we have a look at the product life cycle. So the life cycle assessment helps us to quantify how much and where also we should take some actions. We are also involved in recycling topic is of course something very important, especially when we are talking about thermosetting resins. We do have actions. We are involved in developments. We are involved in initiatives with universities and so on, and European-funded projects regarding, for example, the Vitrimer technology. Another aspect is the reduction of our environmental impact. So the energy consumption, the CO2 emissions, the water consumption, waste disposal. And finally, the product safety. We have dedicated team of people taking care of the new developments, but also the legacy range, checking if checking in order to not use any substance with very high concern or carcinogenic, mutagenic, and reprotoxic substances. So you can say, yeah, nice, you have a nice pitch here, but what are you actually doing? So here on the next slide, the idea is to bring you some numbers on two of those elements. So the use of biorenewable products or substances has been done for a decade, as I mentioned before. So today we have between 15% and 85% of what we call the biorenewable carbon content in our resin, epoxy resins, and reactive diluents. We have a roadmap, and next year we will have 100% certified. So we will have certified with 100% biorenewable carbon in our resins. And so this is the first step, and then the second step will be also to tackle the point of our curing agents, so epoxy hardeners, and we have a roadmap before 2025. Then in terms of reduction, and we quantify it, so we analyze it with the global warming potential of our epoxy resins, and we started we started already the exercise in 2020, where we started with for example, here 5.4 kilogram of CO2 emission per kilogram of epoxy resin created. And then in 2021, we achieved already, thanks to the management of the energy, the source of energy we are using, we managed already a reduction of 23%, and now we are on the way to decrease it by 70% between 2023 and 2024. So substantial improvements. So here are more short-term elements, but I think it's important to put the actions we have already and today ongoing. So now this being introduced, let's go for the solutions and explain a little bit what we are doing for tomorrow's mobility. So here on this slide, I propose an overview of the epoxy range, which is included in the big picture of the applications, of the products, and the processes. I believe everything is really well connected and interconnected. You take an application, then you have specific requirements, so you put a dedicated epoxy resin solutions in front of it, and then once you have this product, you need, of course, to process it in the right way. And even when you start from the application, you have a specific design, and then you design a process. So everything is really interconnected, so it's important to understand the big picture to bring to our customers the right product and solutions. So in terms of applications, we target structural parts, like body in white. It can be for automotive transportations, but nowadays flying vehicles are also using our mass production systems. Actually in the developments right now. We can replace also leaf springs. We have composite wheels. Now the more emerging applications are related to the battery housings, protection of battery cells, protection of passengers in vehicles, and underfloor panels. And also now also an interesting application which is related to electric motors, and which covers the rotor sleeves, so composite rotor sleeves. And finally, at least, so the last but not the least, the pressure vessels. And with the emergence of hydrogen and fuel cell vehicles, so pressure vessel is something important we are focusing on today. So then, in front of this, we put the ARALDITE solutions, epoxy-based formulations, which are structural, which can cure in seconds. So we have one system curing in 30 seconds, 140 Celsius, without any post-cure afterward. Then we can address also the high thermal resistance. We have systems with TGs above 200 Celsius. We have flame retardant system that can be injected in different processes, or that doesn't contain any fillers or any solid inside. We have toughened system or resin systems which are designed for fatigue resistance, and preforming binder for the mass production. And then in terms of processes, we are collaborating with different partners for the processes, but we have also in-house a nice laboratory where we can address the RTM applications, the wet compression molding. We also have capabilities in pultrusion, filament winding, towpreg winding, pre-pregging, sheet molding compound, And to support the processes, we also have process simulations, and I will talk about this a little bit later on. So, first type of application I would like to talk about is the battery housings and the floor panels. So the objective here is really to protect battery cells and protect the passenger vehicles in case of unexpected event, fire, thermal runaway, things like this. And the objective of having a composite design is really the lightweight, weight reductions. And how we design the products, we always start from the challenges of our customers. We try to understand what kind of standard they need to pass, what kind of tests they are doing, and then we put in front of this the specific properties, like the fire resistance in this case, the thermomechanical properties, and also we need to make it compatible with mass production, because we are talking here about large series of production. And yeah, the elements like being compatible with the electromagnetic interferences. So we developed 3 different concepts. So the concept number 1 consists in using an intrinsically fire-resistant system. So basically, you use whatever fiber you want, then you can process those systems in different ways. They are already fire-resistant. For example, at lab scale, on coupon level, on composites, we pass the UL 94, and we have the rating V0. Yeah, so it's the easiest way, actually, to bring the fire resistance to the component. Then we have the concept number 2 is to use mass production system, more classical solutions, which are already qualified and running in production. And we leave this decision to the customer to use a fire-resistant surface or a fire-resistant additives that they combine together with those resin to bring the specific properties. And then the third concept, for a little bit of freedom about the design and the shapes, and it's well suited for battery covers, is the epoxy SMC. The benefits also of epoxy SMC compared to other SMCs, classical SMCs, is to have a very low VOCs and styrene-free chemistry. So here are examples of few resin systems. So we have a full range, a portfolio, to be able to adjust and adapt to the requirements of the customers. So second type of application is the rotor composite sleeves. So the idea is to reinforce, actually, and maintain the structural integrity of the rotor during very high speed rotations, above 15,000 RPMs, in a range of temperature from -40 to 180 Celsius. So we do have a system which is dedicated to wet filament winding with a low viscosity and a high thermal resistance up to this 180 Celsius. Then the pressure vessels. So we have 2 elements here in the pressure vessels, which is on one side the safety, because we are talking about here very high pressure storage systems, and the productivity, because now the projections in the future are quite incredible. So increased productivity is also something we have to tackle. So Huntsman Advanced Materials has been involved in the developments of pressure vessels for more than 15 years. We started with the compressed natural gas. We have a full track record of products already qualified in those applications, in running automotive programs. And more recently, we qualified at least 3 different systems to the hydrogen 700 bar storage systems. And so our strength here is really to have a close collaboration with our customers. We understand their challenges. We try always to understand what exactly they need, and then we put the right solutions in front. So in terms of solutions, we again tackle different manufacturing processes. The wet filament winding, the RTM, it can sound a little bit strange for this kind of shape, but for small vessel design, it can make sense. And then finally the towpreg winding, which is kind of growing application now, and especially in Europe. Now we see some developments and interesting. I will develop a little bit more in the next slides. And so starting from those requirements, then we developed the resin systems with very specific thermomechanical properties to make sure that the safety is ensured. So with specific strengths, specific elongation at break, fracture toughness, and thermal resistance. So let's start with the wet filament winding. So it's a well-established technology used for decades and decades. And so it's a proven technology. And we have a portfolio of products, a little bit diversified. And this is not the only platform we have. We can also play around with different platforms, but here are reported 3 different resin systems with long pot life, fast impregnation, and very good thermomechanical properties. The second type of process, resin transfer molding. So how does it work? You have a liner, you braid, or you make a dry preform around your liner, and then you put this into a tool, you inject under pressure, and you demold, you have your part which is ready to go. The advantage is that it's a clean process. You can reduce the manufacturing times. The in-mold cure time can be quite low, so 20 to 30 minutes. And the epoxy resin that we have developed specifically for this application has a high fracture toughness for excellent dynamic properties, so cycling test compatibility and so on. Then the towpreg. So the towpreg is also a clean process. We've been working for years now on the development of a product range. We started our developments in Asia, so more precisely in Japan, with some experimented partners. And now we are bringing this technology worldwide, working with different partners, because our target is not to sell the towpreg directly to the industry. We are selling the formulated resin system that will be used by different players, towpreg manufacturers, end-use customers that would like to make it in situ, and or even it can be carbon fiber manufacturers. So our specialty is really to develop the resin system in collaboration with those partners. So the advantage is, clean process, very consistent and controlled resin content, and very fast winding speed. On the machines we can run now with 5 meters per second. So then a few words about the proven mass production process. So this is not really new in our portfolio, but at least it's running in production. We do have several resin systems for high pressure RTM and wet compression molding with very fast cure times, which are also highly structural. And the same for leaf springs, where we have been focusing on fatigue resistance, so we're generating a lot of data on the parts, on the coupon level. So for example, here some SN curves that we've done on those 2 examples of resin system. Also compatible with high pressure RTM or pre-preg, depending on the requirements of the customers. Then a few words about the customer support, because the intention of the customer support is to make the best use of our materials. You can have the best resin systems and the best mechanical properties you want. If you do not use it in the right way, you cannot take the benefits of these things, of these advantages. So then this is the purpose of the customer support. So we support with simulations. It's mainly related to pure kinetic simulations. Then we have very nice capabilities of testing in Basel in Switzerland. We have an ISO certified laboratory, which can also help our customers to save time during their developments. And finally, we have a nice processing lab. So just a little bit about simulation capabilities. So here is an example with pressure vessels. So what does it do? So most of the processes, you have input of products, you get to a process of temperature, for example, but you don't really visualize what's going on live. So you make trials, error to try to identify what kind of curing time I should need, what kind of temperature should I work with. So the advantage of the simulations is to visualize what's going on. So the first element is we can ensure safety, because if, for example, you have very thick materials, and it's the case for pressure vessels, type 4 pressure vessels, 700 bars, sometimes you go up to 40 millimeter thickness. And there, if you put a pressure vessel directly at elevated temperature, you will have a temperature overshoot, which can have a degradation of the resin system, which will lead to porosities, to every kind of defects you don't want to have. So having the simulations helps to prevent those risks. Also, not to have degradation of the liner material, for example. So we can really prevent to have those risks and keep the process under control. Then we can develop reduce the development times, because we can limit the iterations, the number of iterations. So basically, we select the resin system at first, and we give some recommendations, initial recommendation parameters. And then in terms of productivity at the end, we can optimize exactly the processing time. Not too long, not too short. You have exactly the right curing time. So all in all, we are active in this new mobility, tackling different vehicle applications, battery housing, underfloor panels, hydrogen pressure tanks, battery housing or other structural parts, leaf springs, carbon wheels. So we have a full portfolio and dedicated teams with highly technical skills to serve you and serve this type of market. So it was my pleasure to give this presentation to you. If you have any questions, please feel free. We still have several minutes. Thank you. Okay. Oh, sorry, yeah.
Thank you for your presentation. In
You're
terms
welcome.
of Huntsman's development and research for epoxy, two questions. First, do you have a recyclable epoxy in development? And second question is, for the processability or and translate into productivity, what is the curing time, again, for epoxy? What's the shortest curing time and lowest temperature for your epoxy system?
Okay, so for the first question, as I was mentioning in some slides ago, I don't think we have the slide again, but we are involved in some recycling projects. We do not have a solution on the shelf right now. It's still quite early stage, I would say. I will be we must be honest. It's a difficult topic. There are many actors working on this, and but we do have some actions. We do have some programs ongoing. And we are working on the V3mer technology, for example, to be able to introduce in the near future some recyclability into our product portfolio. For the second question was about the curing cycle times. So I think the fastest cure cycle time we can reach are related to the wet compression molding technology, sometimes high pressure RTM, but wet compression molding technologies. We are capable of curing in 30 seconds, 140 Celsius, and we have no post-cure at all. So 30 seconds, 140 Celsius is what we can do in mass production.
How about the combination, that the lower temperature, shorter time? Can they go hand in hand?
Yeah, that's so. The next question was about the low temperature and short cure times. Yeah, so it's always a compromise to be found, actually, because in a process, I need to check the time, but in a process you need to have the impregnation time, so you need to have enough time to impregnate your fibers, and then to be able to cure, to demold, and have the part. So if, technically speaking, we could be even faster, but the problem is, if you are faster, then you don't have enough time to impregnate properly your fibers. So this is the balance that needs to be found. Just checking. Yeah. So I have 30 seconds to go for one question if you want. Okay, so if not, thank you very much for your attention. And I wish you a nice show. If you want, we are not so far away, all 6 M31. Thank you.